let's take a closer look at the SUVAT variables and the many and varied equations that we can use to play around with them. Now, let's start with looking at what SUVAT is, and then we'll have a look at the equations. So, when we talk about SUVAT, we're just using an initialism of a bunch of different variables, namely S, U, V, A, and T. Now T is of course time, A is acceleration, V is final velocity, U is initial velocity, and what starts with S but displacement? So, when we're looking at the motion of an object, we can describe its displacement, its initial velocity, its final velocity, its acceleration, and the time of its motion. And these 5 variables we can use in what we refer to as the SUVAT equations to predict, to calculate motion under certain circumstances. The circumstances in which we use this is when we're looking at 1D, so motion in one dimension only. Now that means technically we can't use it with 2D motion. So if we've got something travelling both horizontally and vertically, or forwards and backwards as well as left and right, or up and down or whatever, then we can't use it as is. But we can with a really easy trick. Namely that if we remember from resolving vectors, when we've got some vector in some direction, we can resolve it into its vertical and its horizontal components, which are now 1D and can be treated separately. So we can use this to look at 2D problems as long as we first break them down into 2 1D problems instead of 1 2D. The other condition is that acceleration must be constant. So as long as we've got constant acceleration, we can use this to have a look at 1D motion. So let's look at the equations. Here they are. There's actually 5 here, separated by these semicolons. So we've got V is U plus AT, we've got S is U over V, U plus V over 2 times T, we've got V squared is U squared plus 2AS, S is UT plus half AT squared, and S is VT minus a half AT squared. Now, this first one, V equals U plus AT, A times T is our acceleration times time, which gives us some change of velocity. So this first one, we can see, is basically saying our final velocity is going to be our initial velocity plus the little bit extra from having accelerated. This one here, S is U plus V over 2 times T. If we look at U plus V over 2, that's our average speed. So this middle one is saying our average speed times time gives us our displacement. This one you can get from some funky maths, and these two are a bit more complex. We might look at some graphs and how we can use graphs to help us calculate these ones later. Once you've done a bit of calculus, these bottom two fall out quite nicely as well. And once we get on to kinetic and gravitational potential energy, there's a really nice way to derive this one over here too. But there are these 5. In general, you'll probably be given these formula in any exams which you sit, but it's good to familiarise yourself with them, and to be honest, if you've not practiced so much that you haven't memorised them by the time you get to the exam anyway, then you've probably not practiced enough. Now, let's have a look at how we actually solve SUVAT problems. So there's a really nice, easy method. Once we've established a question is asking us to do a SUVAT calculation, there's a really nice easy method which we can use to help us make sure we get the right answer. So let me take off some of this extra stuff I've put here, so that we're just back to our initials, S, U, V, A and T. So let's come up with a question, and we can have a look at how this method can be used to solve it in a quite straightforward manner. And for the question, let's say, so let's take a little object and we're going to drop it. But we're not just going to drop it from rest, we're going to throw it downwards a bit. So once we let it go, because we've been throwing it down, it's already travelling downwards, so just in one dimension, we're not going horizontally as well, with a velocity of 5 meters per second. And let's say we know, or measure, or time, or whatever, that it takes 3 seconds for it to reach the ground. With this information, we've actually got enough to work out both this distance that we've travelled, this displacement, as well as the final velocity when it reaches the ground. So let's do these one at a time. So the first thing we want to do is decide on a positive direction. So we have to, in this 1D, we have to pick a direction to be positive, and we're going to take that direction, let's go for downwards to be positive. What we're going to do with these 5 variables that we've initialed, we're going to go through, we're going to work out which ones of these we know and which ones we want to find out. So let's start with the displacement question. And let's start filling this out. So the first one, S, the displacement, well, that's what we want to know. So let's stick a question mark next to that. Our initial velocity, that's, well, that's plus 5 meters per second. So it's 5 meters per second and it's travelling downwards, and downwards we call positive, so that's that. The final velocity, for the moment, we don't care about that, so we can ignore that. Our acceleration, well, we haven't been told that, but because we're on Earth and we're in free fall, that's going to be 9.81 meters per second downwards. Downwards, I've said, is positive, so we're going to give this a positive sign. If we decided to give upwards a positive direction, then we'd have to take care and make sure this was negative. So if up is positive, then we're accelerating downwards, which is negative. For the sake of simplicity, in terms of calculating through this video, I'm going to use 10 meters per second. The true value is of course 9.81, and this is positive as we just said. And the time is 3 seconds. So we've identified 3 of the variables that we know and 1 that we want to know. And as long as we know 3 of these 5 SUVAT variables, that is enough information to work out the remainder. So now we've got the 3 and we want to find S, we've got to pick the right equation. Now if we have a look at these equations, if you look carefully, you'll notice there's 5 equations and there's 5 SUVAT variables. And each equation is missing one of the SUVAT variables. So this one over here, B, U, A and T, so this equation doesn't have S. This equation here doesn't have A, this one here doesn't have T, there's no V in here, and no U in this one. And so, because we've got 3 of these, and we want to find a 4th, we don't care about the final velocity, we want to pick the equation that doesn't have V in it. And so that was S equals U T plus a half A T squared. Now I've got that equation, I can just substitute the values in. So you can see it's a fairly straightforward process. Work out a direction to be positive or negative, work out which values we know, which ones we want to know. Using those we pick an equation, we put the values in, and out pops the answer. So U is 5, T is 3, so we've got 15 plus a half times A, which is 10 for now, and T squared, that's 3 squared, so that's 9. And that's going to give us 15 plus 5 nines is 45, which gives us 60. So our displacement is 60 meters, and we can see this has got a positive sign, and so our displacement is downwards. If this had come out negative, then our displacement would have been up in this direction instead. So our displacement after travelling 3 seconds, having initially started at 5 meters per second, is 60 meters. Now let's have a go at finding v. So if I clear off our little working space in here, and this time we're going to find our final velocity instead of our displacement. We know our displacement is 60 meters. So let's clear this and let's clear this. Now in theory we now know what our displacement is. We've got a displacement of 60 meters, so we could record that up here. Oops, I've just noticed that should be per second squared, shouldn't it? So 60 meters up here. And so now, because we know all 4 variables, and it's just v that we want to know, we could use any of the equations with v in. So based on this, we could use v is u plus at, we could use s is u plus v over 2 times t, v squared is u squared plus 2as, or we could use s is vt minus half at squared. However, if we have a look here, this 60 is one we calculated. So if we did that wrong and used this s value, then we would carry that error through and get a wrong value for v as well. So instead, we're going to prefer to stick to the original 3 which we were given in the question. So that's u, a and t to find v. And so this time we're going to use v as u plus at, that's the one without s. So v is u plus at, which gives us 5 plus 10 times 3 to give us 35 meters per second. Now you'll notice with this question and with the bit where we were finding s, we didn't actually have to rearrange these equations at all. Now that's just coincidence, that's just fortune in this case. In general, it's quite likely that having picked one of these equations, you'll need to rearrange it as well. So for example, it might be that we were given our initial velocity, our final velocity, and our acceleration, and we wanted to find the time, in which case we'd have to rearrange this first and then substitute in the values. So this is the SUVAT variables, our displacement, initial and final velocities, acceleration and time, and this is the general method which we would use when tackling any SUVAT problem. First, establish a direction to be positive or negative, list our 5 SUVAT variables and note next to them if we want to know it or not, and if we already know it. So the s, in our first case, we knew we wanted to know s, so we marked that as the one we wanted to find. Didn't care about v, so we put a mark next to that, and the u, a and t we knew, so we filled that in, taking care with our signs. Once we've done that, we picked an equation, then we perhaps would have to rearrange it, substitute in, out comes your answer. Nice and simple.